Hi, my name's Dan, and this video is one in a short series of videos that I'm doing about registers, which are a component in CPUs, which in turn is part of a much larger series of videos that I'm doing, which tracks the a progress from fundamental logic gates in digital electronics through to the creation, well, the simulation of a simple 4-bit CPU. So as we're going through this process, we've gone through uh, some quite basic but very important pieces of digital circuitry, and we're starting to move into specific components that are going towards making up a CPU. And this short series of videos is about registers, which is part of that. If you want a roadmap of where we're going in the larger scheme of things, that is available in the description below the video. And um, and also there is a link there to this software that I'm using, which is DigitalWorks, which is digital circuitry simulation software. I'm doing this in a simulated way rather than a hardware way. A, because it's cheaper, and B, because it's more visual, and so you hopefully able to understand what's going on. And I encourage you to get the software and to play along with me and to make this CPU. But if you're just jumping in here, then you might need to go back and do some stuff from the previous videos. As I say, look at the roadmap that's below if you want to know more about that. So we're talking about registers, and um, we're still not actually making anything in this video, but I want to talk about how registers talk to each other. And if you've been watching all of these videos in sequence at the end of the series on multiplexers that I have just done, I talk about bus access and how components can communicate with each other using a thing called a bus. I'm going to quickly reiterate this, which is rather than having lots of dedicated wires and lines from each component to each other component, computers use a common set of wires called a bus. And the limitations of a bus is that you can only do one data transfer at a time over a bus, but the advantages are huge in terms of you actually get speed up because things can be smaller and closer together, um, and uh, and then of course you need fewer components and less wiring to make these things work. So this that we can see here in DigitalWorks is a kind of dummy up of three components named as generic components. There's actually nothing inside those macros. They're just boxes to show this connectivity. And these are connected to the bus, so there are three components. And when you have registers, uh, almost always your register will be connected to at least one bus. Um, there is a main bus which most of them will be connected to, and when a data transfer is happening from one component to another, and registers and CPUs have a lot to do in terms of data transfer and moving numbers around, then one of these components will be connected so that its bus connections here are output, so that it actually effectively, you call it writing to the bus, but it actually determines the status of the bus, which lines are high voltage, which means a 1, which lines are low voltage, which means a 0 in your binary numbers. Um, and then when a component is doing that, so the data is then being held in the bus, any other components can read that data. And each of these components has two pins, one of which is output enable, which says I'm going to use my bus connection as an output. And the other is bus read, which says I'm going to use this my bus connection as an input, and I'm going to if it's a register, I'm then going to store that internally, is usually the thing that's going to happen. So there's a fundamental important principle in digital logic circuits that comes into play here because we've got so many different things potentially attached to the bus, and because more than one thing can see this as where the data is being output to. You cannot connect an output from one gate to an output to another gate? Well, physically you can, but you're inviting all sorts of problems electronically if you do, and this simulation won't allow it to happen inside Digital Works. So you need to be careful that you're only actually connecting one component, which is output enabled at any one time to the bus. You can have none, and that's fine, but you can't have more than one. And that presents us with a fundamental problem because we want to do this in hardware. And how are we going to do it? Well, the normal way to do an enable is to use an AND gate, but then you're connecting your output from your AND gate to your bus. And you're doing that in all your components. So you're still actually connecting several outputs from different gates to the same thing, and that's still the thing that's not allowed. So we're going to need a clever way of not just enabling, but actually switching off contact uh, between the gates that are part of the component and the wires that are the bus. And so for that, we're going to need a special component, which is called a TriState Buffer. And at this point, I'm going to stop because the next video is going to explore what a TriState Buffer is, what it does, and how we can use it in terms of access to a bus. So that's it from me for now.